Welcome to the Maintainable Software Podcast, where we explore the art of improving existing software with seasoned practitioners who have helped organizations work past the problems often associated with technical debt and legacy code. I'm your host, Robby Russell. On this episode, Matt Wynne joins us from Nelson, British Columbia, Canada. Matt is currently a co-lead of Cucumber Open and a BDD Advocate at SmartBear. Matt Wynne, we're so glad to have you join us today on Maintainable. Welcome.
Thank you very much. It's great to be here.
So as you reflect on your vast experience in our industry, what do you believe are a few common characteristics of, dare I say, well-maintained software?
Right, yeah. I remember somebody saying there's a feeling of working with a toy example, right? Like if you take a tutorial or something, where the code's like sort of ridiculously small. And I think ultimately the thing I'm always trying to aim for with software that I think is well maintained is that it feels like that toy example to work with. It's sort of easy to understand and it's pleasurable to change it. Yeah, I think it's important that people that come along and work with it enjoy the experience of working with it.
When you say enjoy the experience of working on it, is this like we're trying to find joy in our work, or are you someone that believes that like software development should be like the really good software engineers are passionate about programming?
Okay, so there's two questions there. So you could get me going on my hobby horse about passion, because I think that passion is not something we want to see in the workplace unless we're talking about politics, in which case, sometimes it can be important to be passionate about these things. But actually, when we're talking about software engineering, software design, really those are things we should be able to be quite objective about. So passions don't necessarily really need to come into it. Equally, I read a book called Zen and the Art of Motorcycle Maintenance many, many years ago, and it made a really big impression on me as quite a young programmer. And I mean, that's a whole meditation on quality and what quality is. And one of the things that really struck me was this passage where he talks about the meaning of the word enthusiasm. And enthusiasm comes from the Greek word, which literally means like filled with God. Now, I don't necessarily particularly believe in a God in the Christian sense, but I love the idea of being sort of filled with the spirit of the universe. And the idea that comes across in this book is that if people are experiencing enthusiasm while they make something, that kind of spirit is baked into the thing. And that's what quality is. So I think there's something, and this does kind of sound like New Agey and spiritual, doesn't it? But I think there's something about the way the people who are making the thing are feeling and relating to each other at the time they're making the thing that we then experience when we come to interact with the thing and use it later, whether that's as a maintainer of the code in the future or whether that's as a user trying to use the thing that's been made.
What is your take on the metaphor technical debt? Do you use it all? Have you used it? Have you learned to not use it anymore? How would you define it in broad terms? And follow up, how do you believe other people maybe misuse it or mislabel something as technical debt?
Wow, okay, so we could talk for hours about this. So I believe the original definition, Ward Cunningham, who lives not that far from you, I think, came up with, was about the distance that inevitably appears between the model that you build in the code of the world today and the understanding that you have of the world tomorrow. You are always going to be learning new things about the real problem domain out there in the world. So as your understanding of that problem domain grows, you will see gaps in the model that you have created for yourself in the software. So I think the way that Ward was using the metaphor at the time was to say those gaps are kind of like, you could think about them like financial debts, that if you leave them around, they will grow bigger and more onerous and cost you more. So it's a good idea to pay them down quickly, same as a credit card debt. So that's my kind of understanding of the original definition. I think there's a nuance to that, which is that on a team that's kind of responsible enough, they can take deliberate decisions to not implement things or implement things in a way that they know might not work forever. So make kind of shortcuts in that model, build a model that has shortcomings, let's say, because it will do for today, even though they already can see what the real problem domain is like, but they know that they ain't going to need it yet. They don't need a bunch of sophistication and complexity in the model for today's needs of the software. So in order to, get it out and get feedback or whatever, they make some compromises in how they model a system. So that's like deliberate debt taken on with knowledge. I think that it's been misconstrued, though, to also mean, and I'm going to forget who it was that brought this name to me recently on Twitter, was the idea of technical dirt, where we basically just like leave a mess. And either that is done accidentally because like we're in a rush, or we don't know any better because everybody on there isn't anybody on the team who knows what it's like to work in a code base that's like that toy example, so they don't have the standards. And they can't refactor themselves out of the place that they're in, so they think it's good enough and they leave it. So there might be a sort of accidental reason that you accrue technical dirt. Or it might be deliberate again, but it's different to technical debt, deliberate compromises in your model, where actually you do like a crap implementation of something because you think you haven't got time and you leave it as it is. But those are sort of different. But I think the meaning of technical debt has drifted to probably more often mean those latter two things, which I think weren't part of the original definition and are really more about just kind of the mess that we end up leaving for ourselves too often.
Would you classify, let's say, when you fall a couple versions behind and say Ruby, even at just like a basic level on your application, would you consider that technical debt or technical dirt?
Yeah, it's not dirt, is it? Because you didn't, the time when you implemented it, that was the latest version of Ruby.
Hopefully, yeah. Sometimes I wonder how that kind of falls into it. It's like, oh, we're outdated on things. Like, is that, it doesn't matter what we call it, I suppose, but I think sometimes you just have...
This comes back to, though, this issue about, like, the burden of maintenance. I mean, that's what this podcast's about, right? But the burden of this idea that software is really a liability rather than an asset, that the things that's the asset is the features that the software gives you, right? That your users are able to do these things and hopefully they pay you money for that, or it provides them with value. But then all of the code that you have in order to give them that functionality is a liability, because every day it's going out of date, whether it's because the model's going out of date and the customers are wanting it to do something different, or because, it's bit rotting. The libraries are getting updated and turns out there's a security vulnerability deep in the dependency somewhere. And the more code you've got, the more of that is happening all the time, the more of that liability you've got.
And while I'm moderately familiar with Cucumber, could you provide our listeners with a bit of an overview of what Cucumber is and how it fits into a developer's team's toolbox?
Yeah. So Cucumber is a tool for running acceptance tests. And the magical bit about it is that the way you express the acceptance tests, the whole idea of an acceptance test is it's supposed to define what makes the software acceptable to your customer or stakeholder, product owner, whatever you want to call them. And the magic of Cucumber is that you can express those acceptance tests as totally business readable examples. So they read like plain English, like you might see in one of those old Word documents for writing business specifications that we used to have to use in the 90s, except you can give them so a human can take them and read them and go, yeah, that's what I want it to do. No, that's not quite what I want it to do. And then Cucumber can also read them and run them against the software and say, yep, that's what it does. Yep, that's what it doesn't do this. So it becomes like this living documentation for the system where you're able to start actually banging together the heads of these two tribes, the people who have the money and the problems and the people who have the solutions and the skills. We know how difficult it is to get those two tribes to communicate effectively with each other. Well, we end up with this, like in anthropology. You talked about archaeology earlier on. So in anthropology, they talk about a boundary object, where there's like a place where two different cultures meet. And the feature files that we feed to Cucumber, the place where you write these examples down, these acceptance tests, can become like a boundary object between the people that want the code and the people that can make the code. And so it can kind of tighten the loop and help people to get on the same page, as it were, about what they want the software to do and what it actually does. And then as a developer, it becomes, if you're into TDD anyway, it becomes a really lovely kind of outer loop around your TDD, because you can define an example that says, right, I want the software to behave like this in general, and it's a really nice, easy way to read that even if you're exhausted, you can read it and fully understand it. It's very simple to read it and understand it. There's no technical jargon in there. You can get in the morning and run that, and Cucumber will go, well, you've made it do this and this, but it doesn't do this yet. And then you can go into your inner TDD loop and actually, work on your model to make it do whatever it is that it doesn't do yet.
What's the difference between TDD and, say, BDD?
Well, depends who you ask. In my view, there isn't. So the way I've explained this before is BDD just formalizes the good habits of the best TDD practitioners. So a lot of people think of TDD as just doing kind of like micro tests, like, I'm writing a small unit test for this class or method, or implementing a bowling game or whatever. But it's like low level small tests. And actually, if you go back and read the literature about where TDD came from, they were always starting with a customer test. They were always starting with a customer acceptance test, watching that fail, and then going on and doing all of the low-level, smaller, fine-grained tests that you needed to make up the pieces of the puzzle before that big customer test started to pass. It's just that that's not what has been popularly understood as what TDD is. So BDD reminds us that the customer tests are important. It gives us these frameworks like Cucumber to help us to run and express those tests. And then there's some techniques that have come out of the BDD community that are really valuable as well. So Seb Rose wrote this book with Gaspar Nodge about BDD, and in fact they're writing a series of 3 books, and they've broken BDD down into these 3 practices: discovery, formulation, and automation. And you can think about automation as being the TDD bit that we know about. Formulation is the bit where you take these examples that you've talked about and formalize them in this structure that Cucumber can understand but humans can also read. And then the discovery part is the bit is really fuzzy and is not really anything to do with computer programming, but it's incredibly helpful as a practice. So, you might, if you do Scrum sprints, you might call it backlog refinement or grooming, where you take, and I've seen a lot of teams often, they'll spend a whole afternoon taking a massive batch of stories, and by the end of the afternoon, everyone's eyes are glazed over and people are drooling. Whereas with discovery, what we have is some techniques to use, maybe 20, 25 minutes to just break things down into examples that can then feed really naturally into the rest of the flow.
Why do you think so many engineers find TDD challenging?
Well, it's hard. And I think it's particularly hard in a brownfield code base. If the code base, it's because really TDD is as much about object-oriented design as it is about testing. And if the code base that you're already working on has got a really horrible object, or maybe it's in a language like Java or Ruby that could be object-oriented, but actually it's just crappy imperative procedural code, it's really difficult to do TDD in a code base like that, because everything's all coupled together and you can't isolate little modules. And so we talk a lot in TDD about this idea of listening to the test. If it's hard to write a test, classic thing is mock objects, where people complain about, mocking's terrible because every time I change something, all these mocks fail and they're all out of date. Well, the whole point about using mock objects is supposed to be that you're simulating the protocols between your objects so that you can discover what the protocols should be. And if your tests are breaking a lot by accident, that's the test telling you that those protocols are too complicated. So, but there are lots and lots of instances where when TDD is painful, that's because the tests are telling you, they're giving you feedback that there's something wrong with your design, there's something wrong with the way that your modules of your code are interacting with each other. But a lot of people, either they don't have the experience with OO to be able to see what those problems are. They don't have the confidence with TDD to recognize that the pain is actually a signal about those OO problems, and they just go, well, this is crap, this is too hard, I can't do it, and they give up. And quite understandably, I think it's a lot of times, when I go in, like I used to work a lot as a kind of roving consultant, going into teams and sitting down with them to try and add tests into these gnarly old code bases. And honestly, like expecting somebody who is new to TDD to do that in a, 7-8 year old insurance system that's coupled to some IBM WebSphere framework, it's like asking you or I to go and start playing you're a Liverpool fan, aren't you? I'm sure. Yeah, it's like asking one of us to go and play football with Liverpool on a Saturday afternoon. Like it's really, really difficult and a high expectation to put on people who are brand new to the stuff. Maybe you do all right. I would certainly look like an absolute chump if I.
No, I would not. I've only played a few minutes of like proper football in my life. I like to watch it though. I'm actually really good at it on my and FIFA on my PlayStation. I'm not like great at it, but I just recently won the cup like a couple weeks ago for the finally for the Premier League, and I was pretty excited that afternoon. So I'm a winner now.
Hi there. Do you know someone who might be looking for assistance with their Ruby on Rails application? Planet Argon would love to meet them. We're offering a $1,000 referral bonus. Send someone our way, and if they sign up for services with Planet Argon, we'll give them a $1,000 discount. And in return, you'll get a check for $1,000 in the mail, just for knowing the right person. Hop on over to planetargon.com/referrals for more information and to refer someone our way. That's planetargon.com/referrals. Thanks.
Anyways, back to the topic at hand. I'm curious, this whole idea around I've seen that happen a lot too, because in my world, we inherit projects a lot, or we work on older applications and trying to help existing applications and make them more maintainable and such. But that is hard. You go into teams, they're like, well, we learned a little bit about TDD and like our boot camp on these like new apps and stuff. But when there's not an app, when the application comes in and it has a broken test suite that hasn't been touched in several years, it's not passing. So you're like, well, do we get rid of the stuff that doesn't even work? And like, if you remember from that era when you were doing the type of work, do you have strong opinions about removing existing tests? Because I know that, like, also precursor to that, what's your take on code to test ratio as a valuable metric?
Code to test ratio, like how much test code should you have versus how much application code should you have? Yeah, I don't know really. It's been a while since I measured that. I'm not sure if I've got any like relevant metrics. I mean, I think I'd be surprised if in a well TDD code base you didn't have more test than code, because the whole point is to sort of end up with a design that is sweet enough that it satisfies all of these test cases you can think of with very little code. Like that's the beauty, right? When you're doing well, that's what you want to get to. So you have loads of test cases because you've thought of all the different things that you want the code to be able to do, but actually the implementation is small. So I don't know what that would look like in terms of numbers, but I'd imagine you'd have more test code than application code.
When do you think it's appropriate to delete test code?
Well, flickering tests are a real pain in the neck. There's a little bit we wrote in the Cucumber book about dealing with flickering tests, and I have a kind of like a technique for what to do about them if you've got one that you think is valuable enough to keep. And usually if you've got a test that's flickering, so that means like it's unreliable, right? Like Heisenberg tests, you might call them. So, it goes off in CI, the CI is red, you run it on your local machine, it's green. Then a minute later you run it on your local machine and it's red again, and you just can't work out why. And yeah, I mean, they're a great candidate for just deleting because they burn so much energy and time. And quite often the reason that they've got unreliable is because they're slow. So, the feedback loop's slow. So maybe it takes you 2-3 minutes to run the test. So by the time you've got the result, you're actually in another room talking to someone else about something else because you got bored. So yeah, those are a really good candidate for deleting. I think what you want to get back to is I've got this set of tests I trust, and it's green and it runs every time. And then you can start to kind of grow it out again. So like in a Cucumber context or RSpec context, you can tag them out, right? You can tag out certain tests that are unreliable as candidates for either deletion. They're on your kind of hump pile. I'm going to do something about these, but I don't trust them. So you get back to having a CI that's green, even if it isn't comprehensive, and then you can work your way out, because it's really important to have a set of tests that's fast. And let's start with reliable, and then let's go for fast. So fast is another whole topic of conversation, isn't it?
It is, and it's actually where I wanted to go next. Is just, we hear people talk about slow tests as being cumbersome or problematic, but I think some people join teams and they outside of like maybe their experience of going through like learning to become a software developer, these small toy projects, where they maybe learn some TDD examples and things are working really fast because it's a really small new thing, versus when you come into an environment and then they're like, okay, well, it's always taken an hour and a half to run the whole test suite. Is that slower now? I don't know. It's just a lot of tests. And so relative to what, I guess would be my question, like how would you help people quantify that, or to know like whether or not it's slow or not?
So for me, right, on new systems that we've built, and I've built some quite big systems this way, I expect to be able to run the tests like that, like milliseconds to run everything pretty much. That certainly tells me that all of the business logic is working. Obviously, integration with databases is not going to go like that. Integration with, if you've got Elasticsearch in there or something, or you're doing some sort of asynchronous messaging through Redis, and anything to do with a browser is going to be difficult to run like that, but you'd be surprised. I haven't tried these modern things like Cypress, but what I have used quite a bit is we've got a version of Cucumber that runs in an Electron process. So you basically get like a node process that has got a browser in it as well. So you've got Cucumber, browser, and node all in the same process. And you can load, if your backend's also written in Node, you can load your backend into the same process, which means that you've got no network I/O anymore, apart from maybe if you're going off to a database or some other API or whatever. So assuming that you can stub out those bits, you can actually run full integration tests right through the GUI and the business logic on the back end, and they can still be milliseconds fast. Like, it's awesome. And so that's totally technically possible these days. And I think, again, we come back to this idea of listening to the tests. If the tests are slow, why is that? Why is it that they're slow? And if people are tending to write tests in a style that is slow, why is that? Why is it not possible for somebody to express a test for the if statements that have got the behavior that you care about without having to pick up the database or without having to pick up a browser? Why is it that there isn't an option for you to plug the tests in at a slightly lower level that's still... So why is your system lacking that modularity that would enable you to plug your tests into the core domain without caring about the details of, how stuff's persisted or whatever? Is it because the framework that you're using, and I'm not going to name any names, is encouraging you to kind of smear that business logic throughout a bunch of layers and not really give you a home for a kind of a core business behavior that is decoupled from these real world bits like the database?
It's interesting. I'm also curious about, I always wonder, you touched on the code to test ratio maybe not being necessarily super valuable. And I can say from a framework that I work in that the general consensus is that we should have like 80% test coverage.
Oh, coverage. Right. Yeah.
It's like coverage. So it's like test coverage, I suppose. And then it gets murky and like, well, are you including all the JavaScript in that stat? Or, but anyway, maybe, I don't know. But is that even a useful metric? But beyond that, I always sometimes wonder if teams are hesitant to say remove test code, even if it's flaky or super slow, because it's making that metric. Because on the flip side, we're like encouraging people to like have test coverage, and that as soon as that ratio starts to go down, even though you might be having more reliable and faster tests, then it starts to almost look like, well, we're now have enough tests now, and then so it's like, does it create this scenario where developers are less likely to want to remove things?
Well, we're just into the whole thing about metrics culture, aren't we? And games, and I can't remember last time I measured test coverage on a project I worked on. We were actually talking about doing it the other day on Cucumber Ruby because we'd noticed we've had a few pull requests recently that have added stuff that didn't have tests, and then we were going in to change something. We were like, oh, this doesn't have any tests. Woo. Yeah, I think it had one big acceptance test way away from it, but it was very difficult to change this class because it didn't have any unit tests around it. And we thought, well, maybe we should add some code coverage in this open source project and have like a gate in CI that says, hey, hold on a minute, the code coverage has dropped. There's a bot, I've forgotten what it's called, that does that for you very easily, and it just wasn't hooked up in this project. But in general, where the team is practicing TDD and every change that they're making, they're doing in a TDD style, you don't need to worry about measuring code coverage because they are going to not make changes to the system unless it's covered by tests. So it's more about, for me, it's more about changing the culture of the team, the behavior of the team to start practicing TDD than it is about putting metrics around them, which are just going to then force, like you say, sort of weird behaviors like refusing to delete flickering tests that are driving everybody mad.
Do you find yourself more often on the side of team rewrite or team refactor?
I'm pretty unwilling to let go of refactor, but I have done rewrites before. I think what I like is that strangler fig pattern. So actually one of my techniques for refactoring or maybe like redesigning, let's say, rather than refactoring, because refactoring is really more of a sort of small scale thing for me, is to rewrite then delete, even on quite a small scale. You know, that Katrina Owen talk about therapeutic refactoring, where she gives you this example of or this paradigm effectively for doing refactoring, where every time you like press escape in Vim, every time you save the file, you want the test to be green. It's a really interesting game to try and play when you're refactoring. And what it forces you to do is to sometimes, like if you're going to take something away, you kind of knock up the replacement, you build the replacement first, just on a really small scale. But that can be a really useful technique to use in a small scale, but you can also then start to apply that in a bigger scale. So maybe if you've got a subdomain of your system that is, you know, really, really difficult to maintain, maybe you rewrite that as a separate, like Ruby gem, or as a separate microservice. And then once you've got that built and spun up, so that's like a small rewrite, right? A rewrite of that part of the system, you can then wire up to integrate with that. You can then turn off the old bit, delete all the old code that was in that subsystem. You haven't rewritten the entire thing, but you've started to move it over to something different.
We'll be back with our interview with Matt in just a moment. Hi, it's me, Robby. I just wanted to take a quick moment to say thank you for making time to listen to the Maintainable Software Podcast. If you're finding these discussions valuable, please consider sharing a link amongst your peers and or writing a review on Apple Podcasts to help spread the word. Also, is there someone you think I should be interviewing on Maintainable? Shoot me an email with your pitch to robby@maintainable.fm. And now, let's get back to our interview with Matt Wynne. What were some of the factors that led to the decision to rewrite the core of Cucumber Ruby?
Yeah, right. Well, so that's a good example where that code base had grown and grown and grown really organically, and there was like this kind of fundamental pattern in there. It's called the visitor design pattern that was being used. And if you've ever seen a Cucumber feature file, it has like all these different kind of elements to it. And the visitor was walking around the abstract syntax tree of this Gherkin document and firing out messages about all the different little things it found as it walked around the document. And the execution model was all built around that. And it was, to cut a long story short, it was a completely flawed, fundamental way of modeling the problem, and had led to several bugs that were just kind of intractable. And we tried refactoring our way out of this, and there was just like a kind of a leap that had to be made that was impossible to make without deleting really quite a lot of code. And in the end, after having probably like, it was kind of like if you've ever been climbing, right? If you ever go to a bouldering wall and you like try a problem several times and slip off, and try it again and slip off, and try it again and slip off. And eventually we kind of went, right, okay, we just need to find another way around this bit because it's too tricky. And so the way around it was Steve Tuck and I spent about 18 months just every Friday we'd meet up and potter away at building out a little gem that in a hexagon, to use that phrase from the Alistair Coburn's hexagonal architecture, which I'm a big fan of, and we haven't had a chance to drop the name of yet in this conversation. But that was like the inner hexagon of Cucumber. It's the main heart of it that does the actual execution of a scenario, of a test case, and reporting the results out. But sort of abstractive, like reading files off disk or reporting to the console. It's just a model, a set of models that can do that execution. So we built that in isolation, made it work with our knowledge of the domain, of what the domain problem was, and then went back to plug it into the front end again.
Nice. And I know that you're also working on improving the, say, diversity and inclusivity of the Cucumber project. So can you tell us a little bit about like how you're trying to factor that into open source? And I know that's not just a thing that just companies are working through and trying to wrap their head around right now, but as someone that also helps maintain and has created an open source project with a lot of contributors over the years, maybe looking to get a little bit of free advice here on what you're learning.
Yeah, well, I haven't got a lot of advice to give you yet, Robby, honestly. I'm still very much at the trying to stay humble and curious and admit my own stupidity stage, really. When I look around the group of people that are regular contributors to Cucumber, we're very white and we're very male. I know there are a lot of people, at least that are using Cucumber, that don't fit those intersections, and I'd really like to welcome more of those people into the contributor community. And I'm trying to learn about what we can do to make the contribution experience more welcoming in general. So, I mean, having the opportunity to stand on this podcast, right, and say, if you are a person of colour and you're interested in getting involved in open source, and, especially if you're doing TDD or BDD at work, Cucumber is a project that is not just sort of like going to be fine. We're going to positively welcome you because we are trying to make a proactive effort to be more welcoming to a diverse group of people. But I'm really still trying to work out what we can do. I mean, the things we're working on at the moment are just basic stuff, really, about like making sure the documentation, the orientation documentation for newcomers is clear so you can find your way around the code. Because you realise it's interesting for me coming back to the code after like 4 years off it. There's an awful lot of stuff I can see now that I probably couldn't see before, where I'm like, ooh, why is that called that? That doesn't really make any sense, does it? Somebody would probably be confused by that. So we're cleaning up the readmes and making sure that things are signposted. So if you want to come along as a contributor, it's easier to find your way around and know where you can make a contribution. So I think there's those aspects to it, and then there's the sort of the more cultural aspects about how we behave as a community. I'm interested in trying, somebody suggested the other day, of like having a kind of open mob or ensemble where people are just welcome to come along and kind of make their first contribution, and we can coach them and support them in that. I mean, that's one of the things I'm trying to do, is when I see somebody come into a pull request or an issue, is offer to, like, here's my Calendly link, I'll pair with you for an hour and we can try and crack this together, rather than just kind of leaving them to figure it out on their own just from what feedback I can give them through text. Because I feel like it's more important for me to spend my time coaching other people to be able to contribute. And then when I sit with somebody on a call, I can also see, it's a bit like usability testing. I can see all the places where I'm like, oh yeah, I can see how that was difficult for you to understand. You get a lot of good feedback that way.
That's true. I was thinking, I have this open source project called Oh My Z Shell, and I started a couple months ago where I saw some people dealing with some issues, and maybe I'm like, hey, I'm happy to hop on a quick video chat with you for a little bit, and let's do a screen share, and let's just walk through what you're dealing with, like whether it's a configuration thing or installing it. Hey, it's some weird issue or something. It was nice to get to actually see how other people use it that I wouldn't necessarily get to like look over their shoulder when they do it, like maybe a coworker or when an intern comes to our office. So I definitely found some value in that approach too, but I haven't formalized that as a consistent thing. Also, like what you're saying around knowing that's the best use of your time might be to sit down and work with other people through things rather than just taking care of it yourself. Because I know that we're probably contributed a lot. At some point, you're like, I want to be a multiplier of helping other people contribute, and know that you might not want to work on this project forever, right? So we need to have other people that can continue help driving it forward.
Well, I just feel like the scale of it now, of Cucumber, that as supportive as SmartBear is of us and what we're doing, we only have budget for 2.5 people to work on it. And I mean, really, I could quite happily have a team of 6, 7, 8 people working on it if we wanted to all be, all of the stuff that there is to do was being paid. Fortunately, we've got a really healthy community of volunteer contributors as well. So it's just really important to me to feel like that. Yeah, like you say, be a multiplier to just try and kind of get the most out of everybody that does give their time. It's just an amazing thing, isn't it, about open source? It's really amazing. I saw this great blog post from, my mind's gone blank again, the guy that maintains Homebrew.
I don't remember his name off the top of my head.
Works at GitHub. And that blog post is all about thinking about your contributors to your open source project as being like a funnel. So especially for technical projects like Homebrew or OMIZ Shell or Cucumber, where the users are potentially, or at least many of them are potentially maintainers, right? They all have the potential to become maintainers. So you think about it like a funnel. You've got all your users, then you've got the people who are contributing, whether it's triaging tickets or making pull requests. Then you've got the people who are maintaining it by merging other people's pull requests. And there's that funnel, and sort of thinking about that, the same way as you think about the funnel for a product. How do you pull people through that funnel? What are the places where you're losing people?
That's true.
That's how I'm starting to think about that now and start to look for where are the places we lose people along the way.
I like that. I'm gonna have to look that article up by him. And have you heard of Orbit? The Orbit model. There's a piece of software I recently set up, but they're actually a client of ours, and they have like their own team. So we're doing helping them with building out their app. It pulls in information about the people that are starring and forking your project, like on GitHub. Also mapping people that are following, like OMIZ Shell. Like for example, I can track all the people. I get some details, all public data from like Twitter, from GitHub profile information, and also from our Discord servers that we have for OMIZ Shell. So it's like showing me which people who in the community is most engaged, whether that being where there are people that are submitting the most contributions, people that are helping people in Discord, like in their Q&A or support, or like our tech support questions, people that are talking about it on Twitter and like helping each other with things. So I can like start to get, it's almost like a CRM, like a community of users and fans, or whatever you might want to call them. And so it's been a way for me to like, oh, that person's been contributing. I might not have noticed that because I'm not paying attention that closely to the GitHub issues all the time, but I'm like, oh, I can go find their email address and send them a quick little thank you, or reach out to them and start fostering some of those relationships with people. Say thanks to people that I didn't say thanks to in the past that I just completely missed or whatever, or didn't think to take the time to do that. I'll send you a link. It's a pretty interesting tool.
Yeah, thanks.
So curious, a couple of quick last questions for you. So let's imagine there's a few people listening to this episode. I hope there's people still listening. We don't have commutes at the moment as much as we used to, but so they've been at their company for a few years now, and they don't feel like their concerns about the long-term, say, stability of their application, it doesn't feel super maintainable, and they keep hearing, like when they ask if they can do some refactoring for certain areas or optimize some things, I think maybe you would say that as maybe slowing down so you can speed up, and they keep hearing, not right now, maybe later, a few too many times, and they've stopped asking. What advice would you offer them on how to take some action today rather than just say, go looking for a new job?
Well, that was going to be my first answer. I mean, it really, it is a cultural thing. Some organizations or some leaders in organizations, right, need to learn painful lessons about what happens when you crunch software teams in order to come out of the other side of that and realize to operate differently. And I think, the best product managers that I've worked with tend to have had a background in engineering, or at least they've got it about this idea that really you can't control how long it takes programmers to solve problems. The question is, are you giving them the most highest priority problems to solve, and are you breaking them down into small enough problems so that they're not too complex to solve it one at a time? That's usually the thing. So yeah, what do you do if you're in that situation? I think there are going to be places in the code base where it does matter and where it doesn't matter, and pick your battles. Make sure you're not fighting for the maintainability of the thing that hasn't changed for 3 years and isn't likely to change. Make sure you're you're fighting for the maintainability of the thing that is getting changed every day, and if it breaks, it's going to be costly or embarrassing for the business, for the organization, right? It's just that kind of confluence of technical risk and whatever the word is for the business risk at the same time. If you've got an area of the code that's under pressure from both of those angles, that's the place to put your effort in and your rigor. Try using more of these techniques like TDD and pair programming, so you can, or even mob programming, so you can really get the best quality into that stuff first time.
I think that's some good advice for those listening. And where can listeners best follow your thoughts and ramblings or ideas about software development and programming online?
Yeah, Twitter.
I'll definitely include a link to that for everybody in the show notes. And with that, it's been such a delight having you join us on Maintainable, Matt. Thank you so much for talking shop with us.
Thanks for having me. It's been fun.
Maintainable.